Inside a modern shipyard, the air is thick with the roar of heavy machinery and the rhythmic pounding of grinders. This assembly hall is the core of the operation, where blinding blue flashes of welding arcs illuminate dozens of massive steel structures being built at the exact same time. This is the whole block construction method, or HBCM. The goal is simple. Rather than building a ship piece by piece, the yard manufactures it in prefabricated three-dimensional sections that are finished simultaneously before final integration. Before this method took hold, shipbuilding was a slow, sequential craft. As seen here, a vessel was laid down entirely on an open slipway, with workers building from the keel upward in a single continuous line. That tradition ended during the Second World War. When the Liberty ships were constructed in just 155 days, they showed that building at scale meant moving away from custom sequential builds and toward manufacturing independent parallel modules. These large modules begin as flat steel plates. Automated CNC plasma cutters use a high-velocity jet of hot plasma to slice through the heavy metal, following computer-guided paths with absolute precision. To create the complex curves found at the bow and stern, shipwrights apply immense pressure using heavy bending rolls. For the most difficult shapes, they employ line heating, using a gas torch to heat the steel before rapidly quenching it with water to force the metal into the correct hole profile. But joining these plates introduces the shipbuilder's greatest adversary, weld distortion. This diagram shows how extreme heat reacts with the steel, causing shrinkage that violently pulls the structure out of shape. To solve this, engineers use a shrinkage allowance, cutting plates slightly oversized so the cooling contraction pulls them into exact dimensions. At this level, constructing an ocean-faring Leviathan is a granular battle against the thermal physics of cooling metal. Once the internal frameworks are set, they are welded together into massive 3D modules, known as blocks. In advanced shipyards, up to 80 of these separate geographic sections are fabricated concurrently across the facility. To speed up production, shipbuilders utilize a specific orientation. They almost always build these massive blocks completely upside down. This setup allows for downhand welding. As shown on the left, gravity pulls the molten metal smoothly into the joint. It is significantly faster and produces higher quality welds than working overhead, where the welder fights gravity. Once these standard blocks are finished, they are joined on the ground into grand blocks. These can weigh up to 1,000 tons, allowing workers to complete complex joining operations in a controlled environment, rather than inside a cramped dry dock. Because they are built upside down, these units eventually require grand block turning. Shipbuilders use synchronized crane maneuvers to flip these massive steel structures into their final upright orientation without warping the frame. The peak of this strategy is the terra block method. Yards like Hyundai Heavy Industries assemble integrated sections weighing over 10,000 tons on land and use a massive floating crane to hoist the entire structure in a single lift. Success at this scale means gravity and sheer weight become active tools for the manufacturer, rather than physical obstacles to the build. A ship also requires a complex nervous system of pipes, cables, and ducts. In the past, this was a grueling manual process, where workers hauled heavy components through tight hatches and welded in cramped, poorly ventilated hulls, where the risk of injury was constant. Modern yards avoid this through the IHOP philosophy: integrated hull construction, outfitting, and painting. They install the ship's internal machinery and piping while the block is still open and accessible on the assembly floor. The data shows why this matters. Moving the outfitting to the assembly floor improves man-hour efficiency by over 50%, while overhead costs drop by 54%. Shipbuilders coordinate this using 3D digital twins. These models ensure that the miles of pipes and cables installed in separate blocks will align perfectly when those blocks are finally joined together. Shifting the most difficult labor from the dark hull to the bright assembly hall converted a grueling physical logjam into a manageable logistical challenge. The process culminates at the central building dock. Here, towering Goliath gantry cranes lower the pre-outfitted blocks onto supportive keel structures to begin final assembly. At this stage, extreme scale meets millimeter precision. Engineers use total station surveys, high-tech laser systems, to verify the exact three-dimensional position of each massive unit. This precision allows for the half-ship construction method. The bow can be built in one province and the stern in another. Yet, because of the digital alignment, the two halves meet in the water with perfect accuracy. Once the final welds are inspected, the vessel is launched. It leaves the dry dock for the first time, testing its buoyancy and stability as it meets the sea. But despite the years of engineering and massive lifts, the hull is currently a hollow shell, a floating steel cavern waiting to be powered. In our next episode, we explore the final outfitting. We will cover the installation of the main propulsion engines and the construction of crew quarters, finalizing the systems that turn this steel envelope into a floating city.